Okay, so a nice easy way to know how many valence electrons are in an atom is actually to look at the group number that it's a part of. Okay, so everything that is in group number 1, all of these elements, including hydrogen, group number 1, they all have 1 valence electron. Okay, it matches the group number. Every element that's in group number 2 has 2 valence electrons. Okay, now what we're going to do though is we're going to skip over groups numbers 3 to 12. Okay, they don't really follow this pattern that we're going to learn in grade 9. In grade 10, you're going to learn and talk more about these elements that are here. These are called transition elements, in case you're wondering. So they don't follow a regular pattern for valence electrons, so we're going to ignore them. So what I like to say is we're going to go 1, 2, and then we're going to skip over a few. Okay, so we're going to go to number 13. But I want you to look at the last number. So it still follows a pattern. So everything in group 1 has 1 valence electron, group 2 has 2, group 13 has 3 valence electrons, group 14 has 4 valence electrons, group 15 has 5, group 16 has 6, group 17 has 7, and group 18 all have 8, which is our noble gases. The only element that does not follow this pattern of 8 is helium. Helium has only 2 valence electrons, but if you remember, the first orbit can only hold 2. So actually, this is still a full orbit having 2 electrons, but it doesn't follow this rule of looking at the group number, okay? But everything else here, 1, 2, 3, 4, 5, 6, 7, and 8. And actually, this picture here is a nice one. So 1, 2, skip over a few, 3, 4, 5, 6, 7, 8, except for this one here, that's helium. Helium has only 2. Okay, so hopefully that's a nice little trick for you to remember the valence electron count. Okay, so how are we going to calculate the number of protons, electrons, and neutrons for an ion? Okay, so protons is exactly the same. Protons does not change. Protons, your atomic number. The way that we solve for the number of neutrons also does not change. Your neutrons is your atomic mass minus the atomic number, which is your number of protons. But for your electrons, you have to consider how many have been either gained or lost. So what you do is you either add in your electrons or you have to remove some electrons. So if you have a negative charge, that means that you have gained electrons. So there's extra electrons added in. If you have a positive charge, that means that electrons have been lost, which means you have to subtract the electrons that have been lost. Okay, so I'll give you an example. Let's say you have something that's a charge of -3. -3 means there are 3 electrons that have been gained. Like there's 3 extra electrons there. So what you'd have to do is take your number of protons but add in the 3 that were gained. If you have a charge of, let's say, +2, +2 means that you have lost 2 electrons. So what you would have to do is you would take your number of protons, but you would have to subtract the 2 electrons that have been lost. So you have to kind of think, has it gained electrons or has it lost electrons? And then change the number accordingly. So, how do you know how many it's going to gain or lose? It depends on the number of valence electrons. That's why we went through this, right? So remember that the goal is to have a full octet or to have the full 8 in its shell. So it will gain or lose according to whichever one is easier, just like we discussed over here, these ones here. Okay, so let's take a look. So I would like you to pause the video. So pause the video and give this a try. So I want you to figure out the number of protons, electrons, and neutrons for a sodium ion. So how are you going to know something is an ion? You're going to see the charge in the top right-hand corner. So notice how it says Na, and then the positive charge That means your Na has a charge of +1. Nitrogen is showing nitrogen with a -3. So that's the charge on the ion. So try writing the proton, electron, and neutron number for a sodium ion and a nitrogen ion. All right, so hopefully you got the same answers that I have here. So proton number and neutron number does not change. So sodium has 11 protons, 23 minus 11, 12 neutrons. But the electrons normally would be 11 if it was an atom. But because this is an ion and it's positively charged, that means it has lost an electron. Because it's +1, it lost 1 electron. So that's why we have here 11 minus 1. So in total, we don't have 11 electrons, we have 10. For nitrogen, protons and neutrons are exactly the same. So we have 7 protons, we have 7 neutrons, 14 minus 7. But because it's -3, that means it has gained 3 electrons. So instead of having 7, it's 7 plus 3. We have 10 electrons. So you take your element and you have to either add electrons if it's negative or you subtract electrons if it's positive. So remember that metals will always lose electrons, nonmetals will always gain them. All right, so let's take a look. So we have beryllium with a +2 charge. So beryllium has an atomic number of 4. Okay, we'll do the ones that are easy because they're the same, right? Beryllium's neutron number is going to be 9 minus 4, which is 5. Okay? So normally, if this was an atom, the atom would have 4 electrons, right? Because it's the same. But because it's +2, what that means is it has lost 2 electrons. So instead of having 4, we lost 2. So we have a total now of 2 electrons, right? 4 minus 2 is 2. So I'm going to draw the Bohr Rutherford down here just so I have more space. But what we're going to do is the same thing. I'll show you what's different about us. You're going to do your protons and your neutrons inside like normal. So you have 4 protons. And please write down your neutrons as being 5. It's hard to squish in there. 5. Okay. And we're going to start drawing our electrons. But remember, we're not drawing 4 electrons. We're going to be drawing the 2 electrons. So we're going to draw our orbit. And we're going to have our 2 electrons. So that's it. So you have 2 electrons instead of 4. Now, looking at this picture though, how are we going to tell people that this is a Bohr Rutherford for an ion? Well, we're going to add to this. So to indicate that it is an ion, what you do is you put this in square brackets. So you have square brackets around it. And in the top right-hand corner, we put what the charge is exactly like it is in the symbol. So here we have 4 protons, 5 neutrons, and only 2 electrons because it has a +2 charge. So let's look at oxygen. So oxygen would have 8 protons, okay? It has 8 neutrons because it's 16 minus 8. Now for the electrons, for an atom, is 8. But it's showing here it has a -2 charge. So what that means is it has an extra 2 electrons. So in total, it doesn't have 8 electrons, it has 10. So for the Bohr Rutherford, we would have our circle for the nucleus. Our proton number is 8. Our neutron number is 8. Okay, and now we have to draw our 10 electrons. So the first orbit we draw, oh my goodness. Let me fix that for a second. The first orbit that we're going to draw will have 2. Let's just quickly connect that here. Okay, so here we have 1 and 2. And then we're going to have another, of course we need 10, so we're going to need to draw in another orbit. And this orbit will have all 8. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 protons, 8 neutrons, but we now have 10 electrons. And of course, to show that this is an ion, we're going to draw square brackets. And in the top right-hand corner, we're going to write down what the charge is of the ion. Okay, so please pause the video. I want you to try these two. I want you to do a lithium ion and a nitrogen ion. So I want you to think about what the charge would be and then draw them accordingly. So do the P, E, N numbers and then show the actual ion with the Bohr Rutherford diagram. Okay, so I'm hoping yours looks a lot better than mine, but let's talk about what's happening here. So your lithium ion, let's talk about how we're going to know what the charge is first of all. So lithium is in group number 1. Group number 1 has 1 valence electron. So remember, the goal is to get to this full shell. So it's easier for lithium to lose 1 than it is to gain another 7. Also, you can remember that metals will always lose. So when we take a look here, lithium is going to become positive 1. So protons and neutrons exactly the same way as normal. Your electrons, though, normally would have 3 for an atom, but because we lost 1, we're now going to have 2. So your Bohr Rutherford should have only 2 electrons, and it will have brackets with the charge in the upper right-hand corner. So this is the same as saying plus 1. Nitrogen has a charge of -3. Nitrogen has 5 valence electrons, so it's going to gain 3 more electrons to get it to reach 8 to be full. So protons and neutrons are normal. They're in our nucleus, 7 and 7. But the electrons are going to be 7 electrons plus the extra 3, so 10 electrons total. So you have your 10 electrons, brackets, and the charge in the top right-hand corner.